Good morning, everyone. My name is Ted, and I am here doing the unofficial Mac version of Handmade Hero. It's so that you can get started on a Mac and follow along with the series, which has been really awesome. I haven't really done much of an update lately, just because I've been visiting family and Thanksgiving and a bunch of other stuff. But I'm kind of back into the swing of things, at least until Christmas. So here we go. We've got a lot of stuff done. I think last time we finished looking a little bit more closely into sound, and at this point, I think it starts to make sense to kind of transition into dynamically loading the game's source code. So right around this time in actual Handmade Hero, this is where Casey decides to um, take the separate kind of game library code and actually build a what's called a dynamically loaded library. And so dynamic loading is basically what that amounts to is we take the code and you can load it kind of whenever as a part of the while your app is running. And so there's some really solid reasons why you might want to do that. One of the reasons is it actually makes it possible to have separate, so it makes it possible to build the game library or make modifications to the game library while the game is actually running. And so that's kind of a really cool thing. And it's actually really pretty, it may not be useful for a bunch of other areas, but in game development, and I would even go so far as to say front end application development, it's pretty darn useful. It's nice to be able to have a thing running and then to be able to, while it's running, make small modifications to the code, tweak variables. You could tweak things like a character's jumping ability. You could tweak design. There's all kinds of things that you could tweak sort of mid-flight while the game is running if you decide to go in this kind of dynamically loaded library sort of a style. And so what we're going to do today is actually break apart the game library source code into a separate what's called a translation unit from the platform layer code, which is going to be its own translation unit. So if we actually go into our main or our build script right here, you'll see on line 32, we've got this clang command that builds the entire application actually. So it's building the entire game as a single translation unit. And that's not just the Mac platform layer code, which we separated out into OSX main.h and OSX.main.mm, but we also are building the entire game library as part of that because it's included in that compile. And so what we're going to want to do is we're going to want to, at some point we're going to want to have two different compile commands here. So we'll just make a note, maybe like a to do, something like that. Have a separate compile line for the game library source code. And I don't know, to what extent it's super valuable to go over the same kind of explanation that Casey does, but one thing that's kind of important to note, if we go back to this, this is our handmade.cpp file. So this is our game library code. One thing to note is you'll notice that when we call game update and render, which is what gets passed in from the main function from the actual platform layer, we're passing in a lot of things here. We're passing a pointer to all of the memory that we've allocated to the game. We're passing a pointer to the controller input, the off-screen buffer for the display, and we're also passing a pointer to the sound output buffer. And what's kind of interesting to note is it turns out that this pointer to the memory is actually really important, because since we've defined in our platform layer where the memory starts as a particular, so let's go into game memory. So we've actually, when we're doing these internal builds just for testing purposes and for development purposes, right here, what we've actually said is we know where the base address of this memory is. And so that's constant. And the memory itself is actually constant. And so if we're actually passing the same memory into, it doesn't really matter what game library we're passing the memory into. It can be this this library or another library. It kind of doesn't matter, because it's actually going to be the same memory that we had the last time that we ran it. So even if we made small modifications to the game library source code, it kind of doesn't matter, because all of the game state, where the character is, like what the character's doing, kind of all of that stuff is actually it's all the same, because we're literally passing it the same memory. So that's kind of one of the cool things that we're actually able to do when we sort of define a lot of these things up front a little bit more, and take more control at, I'm not necessarily going to say a low level, but a lower level than, say, what you would get if you went kind of with like a more object-oriented approach, or more of a dynamic memory allocation sort of approach. So since we've kind of statically allocated the memory up front, we know that that's consistent. We have the same memory. That doesn't change, right, every time we run the app. So we can just compile a totally different game library that we're passing a pointer to the same memory into, and what we get is that same memory going through different source code while it's running, which is actually pretty cool. I don't think we're actually going to get to that part today. Today we're really just kind of setting things up so that we can load the game code dynamically. So there's kind of a lot of things that we have to do to get there, and that's kind of what this is about. So it's a fair amount of cleanup just to get there, and then to start loading game code dynamically. So be in for kind of a long ride. We may stop after like an hour and a half or something, but we'll make some progress for sure. So right now what I'm going to do is I'm going to, so what I've noticed here is I'm in my handmade.cpp file. And really a lot of this stuff right now, just given that we're about to change how much of this is compiled, it starts to make sense to start moving it into kind of more of a header file. So I think that's what we're going to do first. So I'm just going to see kind of where we are. Okay, so I'm in my, yeah, okay, so code, all right. And so all I'm doing now is I'm just making a handmade.h file that is that's in that same directory. And so what I'm going to do is I'm just going to move all of the stuff that's kind of like more structures, that kind of thing, into here. So that way we can just we'll be able to include those headers in multiple places. So these things like this game button state and game controller inputs, all that stuff, I'm just going to move that. Game input, game memory, all this kind of just struct stuff, we're going to move that right into this file here. And the ordering might not be right. We'll sort of figure that out later, but it's not really a big deal at this point. So that looks good so far. So we're going to do that. And then, yeah, really all we're going to do up here is probably would want to include that in this. So we're going to do a pound include handmade.h. And we're kind of just going incremental here. So I'm just going to build, oh, that's right. So, okay. All right. So now we're going to just build the same executable. We're probably going to get a few. Okay, so that's didn't have any issues there, moving things out into a separate H file, so that's good. Now we kind of get into a few other sort of minor changes that happen throughout some of Casey's days before here. So one thing that he did is actually he moved the sound code into two separate things. So we actually want to do that first. We've got game update and render, and that takes a bunch of stuff here. So it takes memory, it takes input, off-screen buffer, sound buffer. And what we want to do is just do a game get sound samples. So we'll just do, right? And all that's going to do is it's also going to take a pointer to the game memory, because otherwise it doesn't really know what the tone hertz state is. And then that's going to take just this sound output buffer pointer thing. So we got that, right? And so we're gonna want that. And then, okay, so that's game update and render. And really what's going on here is like the same thing. So, we pass a pointer to the memory here, and all we're doing is, what I like to imagine here is that it's as if we're overlaying this struct, this game state struct, on top of the start of the memory. So we're pretending that the very beginning of this memory sort of has these variables in this structure in this order. So that's kind of what we're doing. So that's how we get the game state, and we actually then would be able to pass the tone hertz to that. So you see down here, game update sound, we're just going to nab that from game update and render, right? And I'm going to pass, so I'm passing the sound buffer to that, and then I'm also passing the game states, tone hertz. All we did here was just separate game get sound samples from game update and render, and the only reason is because that's what Casey does, and I just want this to be as close as possible in spirit to what Casey does, etc., so that there's minimal confusion. I don't want my game library to be any different from what you're seeing in the series. So that's what that's all about. So, so we've got this, we've got our handmade.h, and then all this means is we just need to change how this OXX main is kind of handling things. So what we've got here is we used to have just one game update and render, and we pass everything to it. So now we're going to actually have two calls. We're going to have game get sound samples, right? And of course, what we do is we pass a pointer to the game memory, and then we're just going to pass pointer to the sound buffer, right? And since we no longer use the sound buffer in game update and render, we split them into two separate functions. They happen to happen right after each other on the Mac platform layer for now, right? We may want, we've separated them. We may want to move them somewhere else. They happen right after each other on the Mac platform layer. There's really no need to separate them, actual need, other than to more closely follow the series. That's really all we're doing here. So if you're kind of wondering, well, that you didn't really. I would not ordinarily program this way. I would, ordinarily I would wait until there's a need to do something before splitting it off into a separate function. But just because in this case where it's a little bit different because we're trying to follow the series a little bit more closely. So just kind of putting that out there as a thing that we're doing. All right, so all I'm going to do right now is just make sure that we can actually still compile this. We're not getting any errors. And we can still compile it. We can kind of test and run it if we want to, but that's probably not super important. So what we've got now is, we're kind of back to the structure that Casey's actually at when he starts to sort of separate things out into the game library. And what we want to do now is kind of like consider the build script that we're going to do, right? So this thing right here, so where I put this to do. So now what it turns out is we have this this compile command for the main game translation unit, and that's all well and good. But I think we're gonna wanna change that. First thing is I already know that we're gonna be using all of the same stuff that we've used in here, right? And so what I kind of want to do is like make sort of like a common compiler flags variable, just so that we don't have to repeat ourselves there. So I'm just gonna do that. So we're gonna put all this like stuff that goes into pretty much every build. That's now here, right? And so and I'm just gonna put that, I'm just extracting that out because it's kind of a pain. And actually, I think we can just do just this. Oh no, wait. If it's like a compound, I think we gotta have the. I forget exactly. So we have our compiler warning flags, our disabled errors, right? And I think we don't actually need the quote there. So, and then this is just, I like this because it just makes it a little bit easier to read, a little bit. We're gonna be using this in two places, so there actually is a need. I'm not just kind of like making this up. So I believe what we do is we just go clang. Yeah, I think it's something like common compiler flags. So we use it again here, and we do game code dot dylib. So dylib is just that's just kind of the Apple sort of equivalent of like a dynamic library of some kind. So that's sort of what that's all about. And then we do -o, and then I think it's -dynamic_lib is sort of the other command, and then .././. Well, I think it's like cpp/code/handmade.cpp. So that's what we'll be. I just want to double check because I before I do any of these, I usually like go through and just follow, just do it one more time to get super familiar with it. So I'm just looking to see if I got that correct. Okay, so now we do G. Yeah, it's like really specific. I forget why the ordering is different for dynamic libraries, but it is. So yeah, .. Okay, so we'll go back. So it's like clang -G-O. I'm just gonna like go back. I'm just gonna have it right up there so I can reference it. So, because I'm not really sure what the reasoning was for that, and I wanna, yeah, okay, so, all right, so then we need to move game code. Yeah, so I don't know. I'm not sure why this actually has to go like before, like what the ordering is, but anyway, so then we do our common compiler flags -dynamic_lib. Oh, that's right. So we have the handmade directory and then CPP code handmade.cpp. Okay, so now we've got kind of our separate compile line, but that's not all that we need to do here because we also have to copy the we want to copy. So in order to actually access this dynamic library, right now what this is doing is it's making the dynamic library outside of the application's bundle directory. And what we want to do then is just move it into the application's bundle directory. We don't only just want to move it into the bundle directory, but we also want to copy all of the symbols into it. So all the debug symbols. That's kind of a requirement. So if we don't do that, then when we're running it and we have Xcode open and anything is happening inside of the game library, if there's a bug or anything like that, then we wouldn't actually be able to like put a breakpoint in and then know where. So you can imagine like we're going to want to, you know, any kind of it's absolutely essential to have debugging and to have a debugger running while you're working on this, because it's just going to be so much more difficult to actually get anything done without one. So we have to copy that too. So you notice what I have here is I've got this bundle resources path here, right? And so all I'm going to do is I have 2 lines down here. By the way, the one on the bottom is the one I'm typing in. I know that sounds kind of rudimentary, but so all I'm doing here is I'm copying the game codes library into the bundle resources path at just gamecode.dylib, right? And then I'm just recursively copying the dsim, because I think the game code dsim dylib.dsim file, so it'll make a dsim file whenever it compiles, because that's the -g command. So dylib/dsim, right? So that's going to just copy the dsim file into that same path, so they'll be right there, and Xcode can then actually use our debug symbols to debug the game while it's running. So even when we change the code and we've got, you know, dynamically loaded code, it still actually works, because it will reload the dsim files. So that looks pretty good. All we're doing is we've separated them out. So we now, instead of having one translation unit, we've got 2 translation units. One of those translation units is for the platform layer, and the other translation unit is for the game code. And so this game dynamic library is kind of its own separate thing. And I believe now if we, you know, kind of run this, we're going to get or if we try and build this, we're going to get all kinds of problems. I think we're going to get all kinds of like linker problems. Probably. Okay, it's worse than that. Yeah. So what I wanted was to just have, okay, so handmade, yeah. All right, so we can kind of, you know, we can kind of go into this. So handmade IH, you know, now basically what's going on is now we're compiling 2 totally separate translation units, and so kind of the ordering of the includes is different. And so that means that some things that used to be available to other files are no longer available, and so we just kind of need to move things around. So what does that mean in principle? Well, you see, the first thing that it's trying to do is it's trying to compile the game library, right? And so it's trying to say, okay, well, on Handmade CPP line 1, there is no such thing as our custom UN32 type. Well, why? Because we tried to compile this file into its own translation unit, and guess what? We didn't include the handmade types, right? So handmade types is what that's actually what's got all of our kind of, you know, unsigned integer types. So try and build that again. All right, you know, it's kind of getting better. So all right, so unknown type. Okay, yeah. So now handmade types, actually, it turns out it had some dependencies, and it's kind of not its own standalone file. Basically, you know, it doesn't know what any of these common types are: int 8, int 16, int 32, etc. I think what happened was when we made handmade types, it was like included after a previous include, which had those defined in it. So all we need to do, I think, is include like std int or something. So we're gonna do that. So we'll just go. So when I said this is going to be a lot of work, I was not lying. All right, I know I do this all the time. I'm actually I forget exactly what. I'll just go back to my resource here. So I know I had in my handmade, yeah, handmade types. Okay, yeah, so it's just this, student.h. I was right. So, okay, we're just going to do that now, include that. What I'm hoping to do is get back to like those linker errors that Casey runs into, just to show kind of what that's, if we can build the two things separately and then run into the linker errors, that'd be cool. All right, so again, more stuff that's not defined. So it turns out handmade.cpp also needs math.h, so not a problem, you know. And again, later on we'll move some of this stuff out, but for now we're going to use math.h, right? We don't want to use math.h. We actually want to, because math.h is not super, it's not super efficient. It doesn't actually use kind of hardware intrinsics. So we will eventually want to replace many of the calls to functions that are inside of math.h with calls to sort of more hardware intrinsic sorts of things, and we would, you know, presumably if you're calling something that's like more of a, you know, a lower level assembly kind of instruction, you're going to get huge speed ups, at least for that particular instruction. So we're going to want to eventually not use this, but for now, just to kind of like, you know, be able to compile the darn thing. Like, all right, okay. Now where are we? Okay, so right. And this is kind of this is kind of where we're getting. So this is sort of a good spot to say, moving on to the next thing, because right here we're already getting kind of this, and we haven't actually turned off this error for unused functions. Turns out that game update and render immediately first thing is giving us this, hey, you know, nobody actually uses this function, right? So you know, we made game update and render, right? Game update. Oh, come on. Okay, and render, right? But nobody's using it. And actually, so I think the reason we get the error is because we said it's internal. And so if we say that it's an external one, and we want to remove the internal keyword here. And the reason we want to do that is because, well, makes sense. Like, it used to be that we had compiled the entire game as a single translation unit, including this sort of cross-platform game library. So we had the Mac platform layer and the cross-platform game library, and they were both kind of combined into a single translation unit. Now we've got two translation units, one for the Mac platform layer and the other for the game as a dynamic library. Two totally separate things. These functions need to be externally facing now, right? Because they're going to be called dynamically from the platform layer. So that's kind of why we had to get rid of that internal keyword here. And so what that means now, I believe, I think it should compile. What I'm hoping is it compiles and then we just get all these like linker errors. Well, I don't want. Okay, actually, wait. This is good. This is what we wanted. So what you'll see here is we've got debug platform for file memory, void star, read entire file, write entire file, LD symbols not found for architecture. So what this, you know, what this basically means here is we have successfully compiled. Well, actually, wait. No, yeah, did we? Yeah, I think we compiled the game code translation unit, but we are now having linker errors. So what the linker is, basically the way this works is you compile the source code files into some sort of a binary, right? And then the linker tries to like link up your function definitions with whatever other stuff that you included from some other place. If it can't find those function definitions, and it says, hey, there's nothing found here, so no symbols found for that particular architecture. That's what's going on here. We compiled the source code, but lo and behold, there's no actual the linker can't find it for us. So that sucks, and that's something that we want to change. basically what's going on is, we can't find these, so we need to change that so that the linker can find them. And this gets kind of more into the more tricky aspects of what it is that we're going to try and do here. So, I don't know that I'm going to be the best at explaining this, but I will give a crack at it. What we want to do is we want to define these files, or define these, we want to, how shall I say, we want to define what those functions are and make them available externally to the platform layer. And we want, I'm not sure I'm coming up with the best answer here, but we want to have some kind of a type for those that's created. So that when the so that when we're linking, we'll be able to. I guess the question is like where do those come from? So how do we know where these debug platform free file memory reference from game update and render? So that function is saying where can we get this, right? And we actually well, we included handmade.h, so we do have this. I'm not really sure why I can't find that, honestly. I'm not sure how much I want to actually kind of go in and talk about this in particular, because it should have found. Well, wait a second. What was it trying to build? So we built the reference from game update and render. Okay. Oh wait, handmade.o. So it seems like we did. What we could do is we could figure out. Yeah, I think that this is coming from trying to build the game library. So I'm not the game library, but the platform layer, I think. I don't want to get too much into this, because there's just so much other stuff that we have to do. But what we want to do is we want to make these symbols kind of available as a. What we're going to do is we're going to do kind of similar to what Casey did with the X input library, and we're going to make these available externally to the game library. Maybe it's that I didn't actually include. Hang on just a second. I am trying to figure out what. Okay, so we have handmade.cpp here. What I think is maybe okay. Yeah, we never actually included the .h, which would have the definitions for those in it. That might be what it is. That might be why we get our linker. So I'm actually going to do cpp/code/handmade.h. Oops. All right. And then because we did that, we're no longer going to include that one, because that's just in the OSX main.h. And yeah, I think it's because we never included handmade.h, which is going to have all those things. So this ought to change how the compile happens a little bit. Oh, maybe this was from the this may have been from trying to build the game library here, because now we get Yeah, right. So there's no such thing as game update and render, and the reason is because we never actually put those in the header file. So we're going to want to do that, and debug platform free file memory. So anyway, yeah. So those aren't being found from here. So debug platform, write entire file, debug platform, free file memory. We're definitely including those, but they're not being found. Maybe I'm honestly not really sure why that's the case, but we'll sort of get into that. Yeah, honestly don't know. But what Casey ends up doing is he ends up going, does like a pound define for each of these things here. So debug, platform, read entire file. And then passing the name. And then, so that's all. What we want to do is we actually want to have a kind of like a type for this function so that we can call that off of the game code. So that's sort of where we're going here. And I actually kind of have to remember what we did here, because that was this is one of the harder things to do, at least in my experience. So I am going to use some kind of, yeah, okay. So debug platform read entire file, yeah, and we have. So what you're gonna do is you're gonna use a name here, and then yeah, it's just gonna put the name right here as. So you use this like debug platform. This is just a macro here. Debug platform read entire file. Then whatever the name of that function is that you want to use as your kind of stub, you would put there, and then it'll just put that function name here, but it'll basically make that file name. So there's that, and then we do like a type def, where now that we've defined the macro, we're actually going to use the macro, and we're going to call it debug platform read entire file, right? So what that's going to do is it's going to say, now we actually have a type that represents this kind of a function. All that type is it's just this same thing here. So it's kind of condensing it into a thing that we can easily reference. And then what we can do is we can actually have a pointer to that function type, which will then allow us to just call that function off of something that can find the address for that function. So that's kind of what's going on there. So we've got, and what we're doing is we're making one just for this special, and it's going to be called debug platform read entire file. We're actually going to use that now, or later on, as a type. And so then we're going to kind of go back down here, and we're going to do the same thing for free file memory. So debug platform free file memory, and again the name, and then I'm just gonna say this right here. So that's the same. The return type's the same. Then name. So then we're gonna do a type def. We're gonna use that same thing. We're just gonna call it debug platform free file memory. It's okay to not understand this the first time you do it. I'm not sure that I entirely do, but what I do understand is that we're giving ourselves the ability to make these kinds of functions with our own names in them, and then have them kind of be externally facing, so that we can sort of easily grab a pointer to that function, which we're going to load dynamically from the game library. So platform, write entire file, right? And we're just going to use pretty much all of this, and we're saying name, right? And then combine all that into one thing. And again, platform, write entire file. Okay, so now we've got all of these kind of separated out into their own kind of function types, and we've got the ability now to make one of these and then have it. We can make a function that has this exact characteristic, which is to say that it's like a function type. So it's got the same characteristic. It returns a debug file result. Whatever its name is whatever name we pass in here, right? And then it takes in a file name or a char star for the file name. And so you can sort of mix and match these things because we're using a type def. They are the same type, which is to say they take the same input and they produce the same output. So hopefully that makes sense. The name is actually not really the important thing here because you know, the type checker isn't really going to care about the name so much as it's going to care about what is this even the same kind of function, right? So the function itself kind of matches up. Just say it's got the same inputs and outputs, and we're just sort of conveniently hiding a little bit of that complexity so that we can sort of easily reference any kind of a function that has this kind of a type, that has this kind of input and output sort of characteristic. That's kind of what we're doing with that. And the reason we're going to want to do that is so that we can do this dynamically. Because what we're going to end up doing is we're going to end up calling these debug read entire file, free file memory, write entire file. We're actually going to, the game memory itself is going to have a pointer to each of these functions. So when we pass the game memory into the game library, because remember there has to be a way, basically there has to be a way for the there has to be a way for the platform layer to know where the functions are, where the functions for the game library reside, update and render and get sound samples. And then there also has to be a way for the game library to know where the platform specific functions are. So if what we do is we say, okay, these platform specific functions, what we're going to do is when we pass the pointer to the memory into the game, in addition to just passing the start of the memory, we're also going to pass pointers to these functions, to read file result, free file memory, write entire file. We're going to pass functions to those so that the game library can call back to the platform layer in the few instances in which it needs to do that. So, hope that makes some amount of sense. Now what we're going to do is we're going to do kind of a similar thing with the two other sorts of we're going to do a similar thing with these two functions here. So game update and render and game get sound samples. So I'm just pasting those. So because we're gonna, and I'm not actually interested in what the actual implementations are. I'm just interested in the kind of doing another pound define around them. So we're going to do some pound define around this. So this is just game get sound samples, right, and then name, right, just as we did. We're kind of defining a type for this, and then name here. And this is the same as it has been. So it's the same kind of characteristic. It takes a pointer to the game memory, and it also takes a pointer to the sound output buffer, right? And then we're just going to do a type def, so that this is kind of a more formally a type, right? And we're just going to call this game update and render, and then then what we'll be able to do is we'll be able to, oh, oops, not game update and render, game get sound samples. Oops. Get sound samples. Right. So what we're gonna be able to do then is when we dynamically load the game library, we're actually going to say look for a function that has this characteristic in the game library and that has this name, and we'll specify a name. But there's actually a function when you load a library dynamically, you can say, give me the name of this function, but then what I'm going to do is I'm going to make sure that thing also has a particular kind of function characteristic. In this case, it doesn't take any, or it doesn't return any parameters, but it takes back a pointer to pointer to the memory, it takes a pointer to the sound buffer. So that's kind of how that works, and then we're going to do a similar thing here with game update and render. So same thing, just replacing this here with the name, so that later on we can use them. I hope I'm, the problem is this is kind of hard to explain, and we'll just kind of go through it though, because if we go through step by step, then maybe we can get some better insight or better way to describe it. So, game update and render, right? Similar thing, got a similar kind of function characteristics. Doesn't return anything, but it takes all of these different parameters, and now we have a more formal type around that kind of a function. So we've actually by type defing it, we've got an official type name that we can sort of easily reference whenever we want to talk about one of these things. So now, what this means, and I'm actually gonna quit out of that. What this means is here, we're gonna change. So we're back in handmade.cpp. We're gonna actually change how this how these functions are written, because we no longer we no longer need to use this same thing here. What we're going to do is we're going to just use our same pound define, right? So why wouldn't we do that? What it'll do is it'll give us the same function. I guess this is kind of cleaning things up, because I'm not even sure if we necessarily need to do it this way, but what it is it's all of these same function types come back to that same macro. They're generated by the same macro. So what this is I think we could keep this the way it is, but since we've got the macro that basically prints out functions that have this kind of characteristic with whatever name we want, the macro, referring to that macro is kind of nice, because it means that if we change anything, if we change something, it means we only have to change things in one place. We change it where the macro is defined, not the macro and any other place. So that's kind of like why we're doing that. So instead of this right here, what we've got is we're just using game get sound samples, and then we're just the name now is going to be this, right? So it's this here, because we've got that macro. It's just gonna do exactly what the macro does. So it's just gonna take what the macro was and just straight up do a textual replace. And it's going to be called, game get sound samples, and then this will be the function name, and it'll have all the same characteristics, and it'll match the type def that we used earlier. So we're going to do a similar thing here with game update and render, and we're just going to call that a game update and render, right? And so that's that. Like not much has really changed there. Um, so, nothing to be too concerned about there. Now, I'm sure we're probably going to get some, if we try and compile this, I'm sure we're going to get some errors or probably linker problems. So, okay, here we are. All right, so actually this is good because, so try to build it, and now what's going on here is it's saying, just as we had here, there is no such thing as this debug platform read entire file, right? It doesn't know where that's coming from. Okay, and that actually makes a lot of sense, right? Because the game library is sort of being treated as its own separate translation unit. So to clean up these, all of these errors, remember we decided that what we want to do instead is have all of the functions that get called in the platform layer, we want those to get called off of the memory that we're passing in. So if instead what we do is we say, let's go back to game memory. Let's go back to, let's see, handmade.h, right? Wait, oops. Okay, so game memory, right? Here. So game memory, we're gonna add a few extra things. And remember that we type defed these, right? So now we've actually got these kind of function types that represent the different, yeah. So we've got the function types that represent a debug platform read entire file function, right? And so what I can actually do is I can say that is, in fact, that's a function type, and we can point to it and we can say that's called, we're just going to give it a name called debug platform read entire file, okay? And we're going to do a similar thing with all of these other kind of functions. So we've got debug platform free file memory, and that's also going to be a pointer. We're going to call that a debug platform free file memory, right? So similar name here. And when the memory gets passed in, we're expected that these are going to point to something. They're going to point to the actual function, to the address of the functions as they are defined in the platform layer. So that's sort of what we're doing here. I'm just using these identifiers here. That's all I'm doing. So that's kind of the expectation here. So now we've got debug platform. Oops, sorry. Platform write entire file. Okay, so debug platform write entire file. So now we've got all of those. They're defined now on the memory. So what that means is when we refer to them, we just need to refer to them from the memory. So instead we're going to do memory debug platform read entire file, memory debug platform write entire file, memory debug platform free file memory. That makes sense. So we're passing in this big block of game memory, and it's got pointers to all these functions, and we're just going to call them off of that. Is kind of how we're doing it. So that's the idea. Now that ought to, I'm hoping that should clean up those particular compile errors. So, all right, undeclared identifier. Okay, so now, yeah, it's just changed. So the nature of it has changed. Now we've just got a different kind of, we've got some different kind of errors. Basically, now the platform layer doesn't really, know where these things are found. So that's a little bit different. So this identifier debug platform free file memory. So let's actually start to look in that. I think this error we're getting because we, okay, so debug platform, free file memory. Well, I mean, I can tell you why. So it didn't find it because it, because it's defined below. So one of the things about C is you need to kind of like move things up. So I'm just going to move that up above where it's used so that it is defined by the time that it's used. Remember, C is very like, it's just going to go straight up and down when it compiles. So that should get rid of that one, right? Okay, so kind of going by, okay, so that got rid of that one. And now we're at kind of a good spot, because basically what's going on is it's saying like, hey, guess what? We don't know where update and render is, game update and render is, and we don't know where game get sound samples is. And that actually, that makes a lot of sense, right? Because we're no longer just straight up including handmade.cpp, and we're saying that there exists a type of function that is like game update and render, but it doesn't actually have that name. So here you can see at the very bottom, we have this macro defined that can like print out a function like that, and we have a type def that represents that function. We don't actually have anything that like can call that function. So that's kind of thing number one. So what we need is just as we have the memory, the game memory has a pointer to debug platform read entire file and debug platform free file memory, and also this debug platform write entire file. We need something on the other side. We need some kind of a structure that actually represents the game code, and that can hang on to pointers to the different functions from the game library, right? So that's kind of thing number one. Another thing I kind of want to do is I just want to like clean up the platform layer a little bit. So I just want to make sure that we're using the same macros that we use to define the debug platform stuff. So you see here how we've got this is the same thing as what we did in the handmade.cpp file where with game update and render. So line 70. We replaced the previous definition, or with just a usage of the macro, because we wanted to have sort of clean code. Basically, what we wanted to have was like, if the macro is used to print functions that are like this, then we want everything to kind of tie back to the macro, and not to have to if I make a change, I want to only change the macro. I don't want to also have to change like a bunch of other places. That's just kind of avoiding duplication, so to speak. So what we're going to do is we're going to just do that same thing. This is a debug platform free file memory usage of the macro, and then the name that we're going to pass in is this here, right? So all the same thing, right? And we're going to get rid of that. What I sort of don't like this on some level, and generally speaking, I would try to avoid writing my code this way, because it obfuscates a lot of things. It's like to know what the parameters are in the input and the output, we actually like have to go back to where this is defined. I don't like that, but this is kind of a special use case. So I'm willing to sort of how shall I say? So is this debug platform? I'm willing to eat the cost of having less of an ability to read and understand this, if it means that we can do this really, really cool thing with dynamically loading the game. So, I mean, that's kind of how a lot of this stuff works. Like there's always there's always trade-offs in every decision that you make, and in this case we're trading a little bit of code readability for this really awesome dynamic feature of loading the game code. Basically being able to load the game, make changes to the game code like while we're actually running it. So we're using this macro, the debug platform write entire file. Hope that makes sense. I think it makes sense. Okay, so debug platform write entire file. So that is going to make one of those as well. And well, all I want to do is I just want to make sure that when we compile this, we're back to square one and we're not getting anything else. And we are, because the macro just spit out the same kind of function, right? So now we're kind of at an interesting spot. If I go back to Handmade, so all of this is, we can start to close those because that's kind of getting where I want it to be. Now we're going to have this interesting. Now is kind of a place where we want to like make some kind of a structure around the dynamic library, which is we want something that kind of cohesively represents like, how shall I say? We want something that cohesively represents whether the game code got loaded and where the pointers are to the functions that we care about in the game library, right? Because this thing is dynamically loaded. When it's dynamically loaded, we need to figure out where the addresses are of those functions that we care about calling. So we need to store a pointer to those functions. So I'm just going to call this Mac game code. That's the name of the structure, right? And it's got a few properties. It's got, I'd say it's got, actually I think it's got like a void star game code. We'll just call it game code DLL, which is like if we actually load the library, the void star is going to point to where that library exists. And then we've got a game update and render star. So this is actually a function pointer to our special type def that's just update and render, right? So this is where our update and render function is going to live. And then we've got a game get sound samples pointer to get sound samples. Okay. And then it's also probably a good idea to just throw in some kind of like an is valid sort of thing, so that if our we would probably want to know if we've loaded the library or not. There may be things we would want to handle if we were unable to successfully load this dynamic library. That's a possible consideration. So we're going back to the main function because this is where we're going to define these kinds of things. So somewhere here, probably doesn't really matter, but I'm going to do it like right after we define frames per second. Kind of doesn't matter. We're going to create one of these Mac game codes, and we're just going to call it game. And it's just a struct, right? And now what we want to do is change it so that game update and render, right? So we've got game update and render and game get sound samples. Well, now instead of us just calling the functions, because we used to compile as a single translation unit, now we're gonna reference these function pointers. So instead of game update and render, it's just going to be game dot update and render and game dot get sound samples. So remember, this is a Mac game code structure, and it has a pointer to the function for update and render. And all we're doing is we're saying, use this address for the update and render and use this for the sound samples. Now what this ought to do is it ought to fix our compiler errors that we were having. And it compiles. But that's only the beginning of the story, because it's almost certainly going to crash. And I will spare you the the video of it crashing, because there's really no point. And the reason it's going to crash is because this is null and this is null. We didn't actually load the code for update and render and get sound samples. So what we need to do is make a function that takes one of these things and that then loads the actual game code. So that's what we're going to do. And we're just going to, you can put it anywhere, but given that we're working in C, let's just define it right above the main function. So this is it's an internal function, and it doesn't return anything, and we'll just call it Mac load game code, right? And it's going to take a few things. I think first thing it's going to take is a pointer to the Mac game code struct that we have, and we'll just call this game. And it's also going to take a character pointer to game library. Let's just say game library in bundle path, or full path, let's call it that, right? And so what that is it's just the full location where we're going to get the game library from our bundle, because it's going to be inside of a bundle. So kind of don't want to go too much into this. Is not super interesting code, so I'm actually just going to, and also just for the purpose of expediency, because again, it's not super interesting code. I'll just walk through this. Let's call it Mac load game code, right? So I'm just going to walk through this and then also do the includes. Got to save a little bit of time here. So I think there's another library that you have to import. It's this DLFCN. So that is what allows us to actually load the game library. So Mac load game code. All right. So the first thing we do is, because remember we're passing a pointer to this game, and we're going to go to the game code DLL, right? And first thing we're going to do is we're going to open. Oh. All right. I'll just call it source DLL full name. Well, whatever. Let's call it game library full path. That's fine. Does not matter. So we're passing in the game library full path. We're going to DL open is just a function that comes from this DLFCN library. That then allows us to open a DLL, right? So that's kind of what we're doing. And RTLD now is just a flag that we pass in saying, yeah, give it to us right this very second. If the pointer to that DLL is valid, there's something there, not null, then what we're going to do is we're going to say the update and render function pointer can be found by taking this. So I'm guessing we can look up some of these. We can look up some of these functions. Why not? So dlsim. So dlsim, right? Oh, interesting. Huh. I guess this is like a Unix. I wonder if there's like BSD. dlsim, free, okay. Manual page for dlsim, okay. Yeah, this may or may not be right. So the void star handle is, so here's the function. Void star handle is saying that's our, that's this right here. This is the handle to the DLL, to having loaded that dynamic library. So we're going to pass a pointer to that handle. And then what we're going to do is we're going to pass a character pointer to the particular symbol name that we're trying to find inside of that dynamically linked library. In this case, we're looking for a function that is called game update and render. And this dlsim, I believe, returns a void star. Yeah, so that returns a void star. And then what we're going to do is we're just going to cast it to our function type. We're going to say, pretend that the void star that you got, for this function pointer actually takes, is the same characteristic as our game update and render function, which takes in these parameters. It takes in a pointer to game memory input, display buffer, returns nothing. Make it have those characteristics, right? Cast it to that type, and be done. And do the same thing for sound samples. So we're looking for functions that are named exactly this. So named update and render and game get sound samples. And then we would say the game is valid if this function pointer is not null, and this function pointer is also not null. And similarly down here, we're probably just want to set them to 0 or whatever. And like have an error. I mean, it's just going to crash anyway, but at least we would know what the dynamic, library load error was. So that's better than like nothing here. This also kind of gets to a point about we need to, since we're looking for exactly a function that's named this and exactly a function that's named this, there's this weird like name mangling that goes on when you do C++, and so because technically we're doing C++, so we have to go and fix the name mangling, or like make it so that the name mangling doesn't happen. So I'm going to do that, and all you do for that is you just do extern C, and then we're just going to extern C the whole file. So that's all we're doing there on handmade.h, and then similarly on handmade.cpp we want to we don't need to extern C the internal stuff, right? But we would need to extern C this right here. So I know someone's probably going to kill me for having this, but you can make a note, I guess. And if you wanted to, you could, move those out. I don't really care, but that's something you could do. So all that's doing is it's making sure that when we that those symbols that the name is that no name mangling goes on for those, so that the name for game update and render, this function is going to be exactly what we put in here as the name for our macro. And similarly with game get sound samples, it's going to be exactly the same name. So the dynamic library loader will be able to find it. So that's important. We want that. Okay, so these are all the things that are going on. So we've got that. We've got the name mangling, blah, blah, blah. We just need to use this mac load game code. So mac game code. Okay. Mac load game code. And now, we've got to do like another one of these lovely making a path for something kind of things. So I kind of do this again. It's not super interesting, so we're just gonna I'm just gonna refer to some code that I've got already because it's just gonna be way simpler that way. Basically, yeah. Yeah. All this is just using the same kind of stuff that we had earlier to make a file path. So the exact same thing that we used to make a bundle file path for the remember the debug load load a file function, and how we had to make a file path that is inside of the bundle path. Well, that's kind of what this is here. Oh, that's right. We also need to make a path. Just a second. Da, 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 da. I actually think that's the same as what we used in the other one. So sorry about this. All right. Yeah. Yeah, so we also needed to do this, make a path. Build an app file path for this path. We'll probably end up kind of moving all of this stuff into more of an official kind of structure, because I think we're going to want to take all this kind of like Mac platform state and sort of like put it all together as one thing. That's kind of like a more final sort of cleanup. But basically, we're doing the same thing that we were doing earlier in debug file IO and loading a file. We want to be able to construct a path for that inside of the games bundle. So this is what we're saying, that once we're inside of the game libraries bundle, then what is actually going to be, or I'm sorry, once we're inside of the full application bundle, then the game library is going to be located at contents, resources, gamecode.dylib, right? And then this is just allocating some space so that we can build the full path of where that happens to be, and then we just use the same function that we used in debug file IO to just build a file path, a path file name, and so that this is going to take where you want that path to be inside of your bundle, and then the output is going to be the full path. So this is the output, this full path, and so that's what we actually want here is game library full path. So that's what we're going to use, and then that should load the game code. That's good. This is still going to crash. The reason it's going to crash is because I was just playing with this before I recorded the video. If you can guess why this is still going to crash, you get bonus points. But basically, it's going to crash because we have not yet we haven't set the pointers to the platform specific functions that the memory needs. So if we remember that here, let's see. Wait, actually, it's game memory. So game memory. Remember how we had this here? Remember how we said that the game memory is actually going to hang on to some function pointers to platform-specific functions like read entire file, free file memory, write entire file, that file IO stuff. Well, we said that those pointers exist, and we're definitely calling those functions inside of the game library on every frame. Or not every frame. I think once when the memory gets created. We're definitely calling them, but we haven't actually hooked them up to anything. So if you try and call, try and dereference a null pointer, then guess what happens? You crash. So we just need to hook these up properly to the actual locations, to the addresses of where they are in this thing. So we've got our game memory. This is like right when we create our game memory struct right here. So all we're going to do is we're just going to say, oops. Okay. So we're just going to say game memory dot debug platform read entire file equals debug platform read entire file, right? And it's the same thing for all of these. We're just saying, yeah, those functions are actually located right where you might think they are. So remember, because we used that macro to define what these are, there is a function that has this name that has the exact same characteristic, the same type that matches what this is on game memory. So all we're doing is we're saying, yeah, those things that are in this file earlier that we defined, well, the pointers for them are wherever those were. So that's kind of what we're doing. Not anything crazy. So game memory. Okay. So now the question is, do we compile? No, we don't. Cast pointer, game update and render, game get sound samples. Oh, yeah, that's right. So this thing, yeah, we get these warnings. It's like pedant. I remember, that's right. I just turned that off. So I'm just going to copy this like pedantic thing. I mean, it's like literally when you're calling the warning pedantic, you know, maybe that's like an indication that it's like not important. But what do I know? So we're just going to do a w-no pedantic in our build script. That's right. It's kind of funny. So no pedantic warnings. Don't really care. Not at least right now. Maybe we care later. Oh, that's right. W-no dash pedantic. Okay, so wait. Oh, that's right. Yeah. All right. Fun typos. Okay. That builds. It builds, but does it run? This is the moment of truth. If I am smart, then so first things first. Let's look and make sure that let's validate a few hypotheses here, or like just do a few quick sanity checks. So here's our build folder. We're definitely building the game dynamic library. We've also got the dsym file in case we want to be debugging it. Now let's take a look at our bundle. The bundle has a contents resources, and lo and behold, just as we wanted, we've got our game code library in that bundle, and we've also got the dsyms in there. So that is overall a very good sign. Oh my god! Cool. So it works. Just as it did earlier. But the only difference now is we've moved. We have legitimately moved the game code into a totally separate dynamically loaded library, so that if we make changes to it, we're not doing that yet. So maybe a good place to. All right, let's recap and then let's talk about where we're going. So, recapitulating what we've done, we took something that was a single translation unit, which represented the game. We used to compile the game's platform layer for the Mac and the cross-platform game library together in a single translation unit. What we've done over the last hour and a half or so is split that into two translation units. One of which is the platform layer translation unit, which dynamically loads the game code's library and then figures out where the relevant functions are and creates pointers to functions back to the platform layer that the game library is going to care about. That's what the platform layer is doing. It's its own translation unit now. We've got this separate translation unit now that represents the game library itself, and it gets dynamically loaded from the platform layer, right? And it has pointers to functions that the platform layer cares about. So now these things are two totally separate things. And what we will be able to do in the next installment of this will actually be we'll be able to set it up so that we can figure out when the dynamic library was last loaded, and then if that library ever changes while the game is running, we can say, hey, go and reload that library again, so that we will have the ability to edit the code as we're actually running the game, which is pretty darn cool. So what we're going to end up doing is, see this, Mac load game code. Right here, Mac load game code is actually in this is happening in the main function before we've ever started running anything, or before we started the run loop. What we'll end up doing is we'll actually move it into the run loop and then figure out If it needs to be reloaded, then reload it, and hopefully we'll get to a place where you've got the whole thing. You've got the ability to kind of dynamically change the code on the fly while you're running the game, which is really cool. So OBS is acting up on me. I don't really want to go do too much more. I feel like the rest of the I'm looking at myself. It's getting kind of slow. So this whole part could be messed up. In any case, I'll just end with saying, see you next time. Support Handmade Heroes. Support me on Patreon if you would like to. I'll upload the source code later. And yeah, enjoy your Sunday.